A very good morning, IB, to our lecture. So we are going to present our group project, which is group assignment about operating conventional machine. We are from section 3, and our lecturer name is Dr. Ho Fu Hao. So I'm going to introduce our group member. The first one is Nur Zulaika binti Zulkifli, Nurul Ifa binti Azha, Siti Nur Aisha binti Muhammad Jun, Siti Nur Diana binti Shamil, and me myself, Nurul Hafiza binti Abdul Latif. So I'll be moving on to introduction. Moving on to introduction, in this project, the latte process, milling process, and drilling process are the three procedures used in this project. So moving on to a latte machine. A latte machine turns a cylindrical item against a tool that is controlled by the user. While the cutting tool is progressed along the line of the intended cut, the work is held and rotated on its axis. Moving on to milling process. The milling process is the most frequent type of machining and it is a material removal procedure. Milling is commonly used to create parts with multiple characteristics such as holes, slots, pockets, and three-dimensional surface shapes. And milling is a technique of machining flat, curved, or uneven surface by feeding the workpiece against a revolving horizontal. And next is drilling process. Holes are created by the revolving edges of a cutting instrument called a drill, which exerts a significant force on the object secured on the table during the drilling process. Cut the piece of metal provided with the hacksaw until it resembles a L shape by following the designed line. Next, on to operating conventional machine. So the first one is the latte machine, the second one is milling machine, and the third one is drilling machine that we are going to use in this project.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zulaika binti Zulkifli, metric number CD200188. And today, I would like to present to you the latte machine for our group project in computer programming. Okay, latte machine is used in all engineering application and in college workshops. Latte machine is used to perform all the basic operation such as drilling, cutting, tapping, turning, and more, with the assistance of various tools placed within the work environment. Okay, next I would like to present to you the specification for our machine. Okay, firstly, the swing over machine bed, which is 350 mm, the swing over cross slide 190 mm, the distance between center that is 750 until 800 mm, then the turning length that is 700 to 750 mm, the width of the bed which is 260 mm, then the spindle diameter in front of bearing that is 60 mm. Then our taper bore according to DIN 228 to MT5, then the normal chuck diameter 160 mm, and the carriage that is 350 until 365, the apron box hand wheel 0.2 mm, the cross slide travel 175 until 190, the graduation of scale across the slide spindle 0.025 mm, the width of cross slide which is 140 mm, and the compound slide travel which is the 100 mm, the graduation of scale compound slide spindle 0.05 mm, the width of top slide that is 110 mm. Then the number of range is 2 times 8. Then the speed range is 50 until 350 revolution per minute in 8 speed. Okay, next I'll present you the Ccodes for our latte machine that we have created from our C++. Firstly, we put the date, of course. Then we put the welcome to our latte machine program. Then we choose the operation of cutting and turning and facing. Okay, latte, they have 3 operations, so we can choose. Then After that, we choose the material that we want to make, which is mild steel, aluminum, and cast iron. Then we show that the maximum allowed raw material, the diameter is 300 mm and the length is 400 mm. Then we have put the working hour. From here we can see I put 12 hours. Then why I said to put the rental material choice, because we want to show the total production cost, so that each of the material has different different has different price. So from here we choose the mild steel, which is 6 ringgit. So 6 times 12 hour, the working hour is 72 ringgit. Then we put the spindle speed. After that, we have chosen the spindle speed is 400 rpm. Then we choose the feed range per revolution is 0.2 mm per revolution. Then we put the raw material parameters. The maximum diameter of raw material is 100 mm. The minimum diameter for raw material is 10 mm. The maximum length for our raw material is 100 mm. And the minimum length for raw material is 10 mm. Then we put the number of cut that we want to cut into the product, which is 2. I put as a for example. And time taken each cut to cut is 10 seconds. Then after we calculate all of that, we can get the result. So the processing time for a product is 7.2 minutes. The solid waste generated by product is 0.015 kg, and the production per day is 100 items. So one day we can get 100 of this product that we want to make. And then the energy consumption for 12 hours is 3000 kilowatt. And lastly, after we record back, the total production for this is $72 because of the material that we choose and the working hours. So we just time, okay, the material that we choose, which is the mild steel, and then we times the working hour, which is the 12 hours, and we get the 72 ringgit. That's all from me. Thank you.
Assalamualaikum and good morning. I am Siti Nur Aisha with metric number 82000091. Now I'm going to present to you about the milling machine in our group assignment. Okay, basically the milling is a process performed with a machine in which the cutters rotate to remove the material from the workpiece present in the direction of the angle with the tool axis. With the help of the milling machines, one can perform many operations and functions starting from the small objects to the large ones. Okay, milling machining is one of the very common manufacturing processes used in machinery shops and industries to manufacture high precision products and parts in different shapes and sizes. So next, we're going to look at the characteristics for the milling machine. Firstly, we use 3-axis milling, and the spindle orientation is universal. Okay, as there are 3 axes, so for the X travel, there are 600 millimeters, 720 millimeter, and 1000 millimeter. For the Y travel, there are 270 millimeter, 300 millimeter, and 380 millimeter. For the Z travel, there are 260 millimeter and 400 millimeter, and the milling machine use 2 kilowatt and 3 kilowatt power. Okay, here are the basic info about the machine. The milling machine is the RAM type universal mill gearbox spindle speeds with Huron type milling head with DRO. Besides, the machine comes standard with the industrial electrics, coolant system, halogen light, gearbox fit on XYZ axis, horizontal milling attachment, and the spindle taper is ISO 40. The spindle speed is around 45 to 1660 rpm. Okay, let's move to the codes. After creating the C codes, here are the output of the C codes for the milling machines. Firstly, we put the machine name and the milling part. Next, we ask for the input such as the cutting speed, the cutting diameter, the number of teeth on cutter, feet, width, length, thickness, the number of holes, the radius of holes, the hole-to-hole distance, the depth of diameter, the energy used, and also the material density. We also include the units, so it's not confusing to enter the inputs. Okay, from those inputs, we got the spindle speed, the feed rate, and also the material removal rate. To calculate the spindle speed, we use the formula of cutting speed times the pi, which is 3.142, and cutter diameter. While the feed rate, we use the spindle speed times the number of teeth on cutter times feet. Next, to calculate the material removal is equal to width times the depth of diameter and feed rate. Okay, next for the operation cost of the part, the user need to key in the product price and the product price per energy and the thickness of the plate. Then we get the time processing and also those results such as machining time, total energy consumption, material efficiency, total operation cost, solid waste generation, and the estimated productivity per day. Okay, that's all for Miley machine. Thank you.
Assalamualaikum and hi, my name is Nurul Ifa binti Azhar and my metric number is AD200140. Now, let me continue the presentation about drilling machine. In a workshop, a drilling machine is one of the most significant machine tools. It is only second to the lathe in terms of significance, and holes may be bored swiftly and cheaply with a drilling machine. The hole is created by the revolving edges of a cutting instrument called a drill, which exerts a significant force on the object secured on the table. The term drill press refers to a machine tool that uses vertical pressure to create a hole. Drilling machines come in a variety of shapes and sizes, each designed to perform well in a given class of work or for a specific purpose. As you can see here, these are the specifications for a drilling machine. We have maximum spindle travel, maximum drilling diameter, taper or spindle bore, distance from center of spindle to surface vertical column, flow capacity, maximum distance from spindle nose to the surface of work table, and then dimensions of working table, motor power, maximum distance from spindle nose to base plate, dimension of effective working area of work table, dimension of effective working area of base plate, and the last one is spindle speed range. So here is the unit that required to follow the specification of a drilling machine. As we can see here, so here is the value. Now, let's see the output that we obtain after we apply the Ccodes of this drilling machine. As we can see here, there are welcome to drill machine, and then we need to enter the dimension of material, which is the length, the diameter, the thickness, the width, and also the energy used. And then we say here, let's begin. Next, it will ask us, how much do you want to cut? So we need to enter the parameters that needs to be drilled, including the diameter, the thickness, the length phase to drill, the rotational speed, feed rate, and also the volume. After that, we can see the result for drilling. It shows the feed rate, material removal rate, total part machining time, total productivity per day, total volume, energy consumption, solid waste generation, total operation cost, and it will ask us, do we want to repeat the process? If yes, we need to enter Y, and if not, we need to enter N. So in this example, we enter N, and then the drilling process has ended, and we also say thank you for choosing us. That's all from me.
Hello doctor, my name is Siti Nurdana binti Jamil. My number metric is AD200128. So I will present about the conclusion. Conclusion: operating conventional machines can be quite difficult to estimate part machining time, total energy consumption, total operation cost, solid waste generation, and estimated productivity per day. However, developing a program using C++ can solve this problem. So in this project, there are three operating conventional machines that we work on, which are letter machine, milling machine, and drilling machine. In three developed programs, we conclude that we get the end product by using all Ccodes we learn in each program. Although we face some problems, like errors during the development of the program, we solve each error with some references. And in general, we can obtain the result analysis by develop programs and have the operating conventional machines to estimate the operation cost and much more. So that's all from us. Thank you.